Hey everyone, today we will deploy the ELK stack using Docker from scratch and build a working centralized logging pipeline. By the end of this session, we will send application logs through Logstash, store them in Elastic and explore them in Kibana. Let's get started. In real-world environments, logs are scattered across multiple applications, containers, and servers. When any error happens, engineer may need to SSH into multiple machines and search different files to find one error. That shouldn't require checking different servers. This is the problem centralized logging solves. The ELK stack has mainly three components: Elasticsearch that stored and search log data, Logstash that collect and processes the log, and finally Kibana. Kibana provides a browser interface to search and visualize them. In short, collect, store, search, and visualize. The log flow is simple. Application logs go to Logstash where they can be collected and transformed. Now, Logstash send the transform logs to Elasticsearch for indexing and storage. At last, the Kibana. Kibana queries the Elasticsearch so the other team can search and troubleshoot the problem and help to solve them. Logstash itself follows three stages: input, filtered, and output. Before starting, we need Ubuntu, Docker Engine, Docker Compose, and terminal access. To verify all the dependencies, we need to check whether Docker or Docker Compose installed in the system or not. To verify the tools, we have to run these commands for Docker version and Docker Compose version. Since we are using containers, we don't need to manually install each services or each component one by one. Our project has three main parts: the compose YAML file that defines the ELK services, the Logstash configuration file that contains the Logstash pipeline, and last, the app.log file. It is the simple application logs that Logstash will monitor. Now, the Docker Compose defines the Elasticsearch, Logstash, and Kibana in one single YAML file. Service define the containers, port expose Elasticsearch and Kibana, environment variable configuration runtime, settings, volume mounts, configuration data, and depends on that controls startup folder. Elasticsearch stores and indexes incoming logs and exposes its REST API on port 9200. This is the default port for Elasticsearch. For this demo, we are using single node mode with security disabled. A Docker volume persists the data. This setup is suitable for learning but not for production. The Logstash pipeline uses three stages as we discussed earlier: input, filtered. The input stage watches app.log. The filter is empty in this demo, so logs pass through unchanged. The output sends events to Elasticsearch using the Elasticsearch service name and store them in daily app.logs file. The Kibana is the web user interface for exploring Elasticsearch data. It runs on port 5601, that is the default port for Kibana, and connect to Elasticsearch using the Docker service name. We access Kibana from the browser and use it to search, filter, and visualize our logs. Now we start the stack with Docker compose up -d command. Docker launches all three containers in the background because we are using -d extensions. Then run Docker compose ps and verify the Elasticsearch, Logstash, and Kibana containers are running and healthy. To test the pipeline, append an error message or any log to the app.log file. Now, Logstash detect the new line and send it to Elasticsearch. We can then use a curl search request against the app.log file index. If the message appears, boom, the pipeline is working end to end. Next option is open the Kibana at localhost 5601. Create a data view using the pattern app logs dash asterisk. Then open Discover. Here we can browse incoming logs and search by keywords, fields, or time range. For troubleshooting, start Docker PS and inspect the Logstash, Elastic, or Kibana logs. Common problems include container restarts, configuration errors, connection failures, and missing logs. In production, also enable TLS, authentication, backups, resource limits, clustering, and indexing retention policies. To summarize, the application logs flow through Logstash into Elasticsearch and are explored through Kibana. ELK centralized logs make searching faster and improves troubleshooting. Logs stop being scattered files and becoming searchable operational data. Thanks for the following. If you have any query or related doubt, please put down them in the comment box. Thank you.